Maths A-level students had a complete nightmare with this question in June 2024. Don't let it happen to you this summer. In the examiner's report, after the exam, the examiner said that this question was very successful in distinguishing the most able mathematicians from the cohort. So that's distinguishing those looking for A's and A stars from the rest. They said a proportion of the candidates struggled, with many responses either left blank or only partially completed. Oh dear, don't let it happen to you. So we start with the substitution. We differentiate it to find dx by d theta. That gives us this. We isolate the dx by multiplying by d theta. That gives us this. Don't forget that when we make a substitution, we also need to change the limits. So the limits before were 0 and a. When x equals a, well, remember what x was? X was a sine squared theta. So a sine squared theta will equal a. We can divide both sides by a, take a square root, and we'll end up with sine theta equals 1, which leads to theta equals pi by 2. If we do something similar with the other limit, if x equals 0, well, this would equal 0. The only way that would happen is if sine theta is 0 or theta is 0. So we can now substitute these limits with our new limits for theta values. We also need to substitute in for x. Remember, x is a sine squared theta. So wherever we had an x, we're going to replace that with a sine squared theta. What else are we going to do? Well, we also have to replace the dx with what we had here. Dx was 2a sine theta cos theta d theta. So that's getting replaced as well. What do we do next? Well, we can apply this power of a half to everything in the bracket here to get a to the power of a half and sine theta. We can also notice that this square root, its contents has something in common. They both have an a in common. So we can factor out the a here. Notice I've also brought this 2a to the front just to tidy things up. We're allowed to do that. It doesn't contain a variable. What should we do next? Well, we can rewrite a to the power of a half as the square root of a. We can also split up this square root into the square root of a multiplied by the square root of this part. What next? Well, the square root of a multiplied by the square root of a is a. Also, 1 minus sine squared theta is cos squared theta. What next? Well, we can combine this a and this a to get a squared, and this sine theta can get combined with this sine theta to get sine squared theta. And this is really cos theta. Cos theta multiplied by cos theta is cos squared theta. Notice that this and this have a square in common, so we can take that outside the bracket here. Why would we do that? Well, we notice that this reminds us of a trig identity. Remember the trig identity for sine 2 theta? That's 2 sine theta cos theta. We're just missing the 2 here, aren't we? So we can put in a 2, but there wasn't a 2 there before, so we have to multiply it by a half. Notice these parts would cancel one another out, leaving us with this part, which is what we had before. Why would I do that? Well, 2 sine theta cos theta is sine 2 theta. So I can then replace that and then apply the square to the half. That becomes a quarter. A quarter times 2 is a half. That's what we have on the outside. Then we have our a squared. And then applying the square here, we get sine squared 2 theta. So we've done it. We've done part A. On to part B. Part B starts with the word hence. That means you can use what you've just done to help you to make progress with this. So what have we just done? Well, we've just worked out that this integral can be written in another way. I've called that integral I, just so it's easier to write later on. How can I integrate sine squared 2 theta? Well, there's a key trig identity that you should know. In general, cos 2a is 1 minus sine squared a. So if I replace a with 2 theta here, because I've got sine squared 2 theta, note that 2a would be 4 theta. So what does this identity become? It becomes cos 4 theta is 1 minus 2 sine squared 2 theta. If I just rearrange this to make sine squared 2 theta the subject, because that's what I've got here, I end up with this. So I can replace that in this integral here. Notice that I've got a half a squared on the outside. A half a squared multiplied by a half gives me a quarter a squared. So that's what I've put on the outside. And on the inside, I've just put this part inside here. So I'm now in a position that I can integrate. One integrates to theta, and this part integrates to a quarter of sine 4 theta. I just now need to substitute in my limits and simplify, and I end up with the final answer.